Alright, welcome. This is 6.7. And so we are dealing with a lot of formulas today. So the three I want you to write down are distance formula, midpoint formula, and slope formula. So we've dealt with these all before, but we're going to use these formulas in a coordinate plane and be able to solve for certain things. And what are we solving for? What's nice is that for the distance formula, we are going to find out whether sides are congruent and diagonals are congruent. For the midpoint formula, this is really useful when we're trying to find whether the coordinates of the midpoint of a side and whether the diagonals bisect each other, so that's going to be really important. And then the slope formula is really important because it will allow us to see if opposite sides are parallel, if diagonals are perpendicular, and if sides are perpendicular. So these three formulas are going to be really useful, and we're going to learn how to use them and when to use them. You should already know how to use them because you've dealt with these before. We've talked about some of these, most of these already, and you definitely used them in previous classes. So make sure that you have everything written down on both sides right there. Okay. Alright, we'll do a few problems. Alright, so our first problem, problem number 1, says it wants to know this triangle on the coordinate plane, is it an isosceles? Is it a scalene, isosceles, or equilateral triangle? So what are we trying to find? We know an equilateral triangle right here means that all the sides are equal. It's equilateral and equiangular. Isosceles, remember isosceles right here, it means that, oh that's terrible, that two of the sides are the same. And scalene means we have a triangle where all three sides are different. So we got to try and find which one it is. And we have this picture right here on the coordinate plane, and so we got to figure out the distance between all three sides, and if they are all the same, equilateral. If two of them, these two right here, would be the same, then it's isosceles, and if none of them are the same, then it would be a scalene triangle. So if I'm trying to look for the distance between the points, I would use my distance formula. So I always like writing down the formulas so I know exactly what they are. So it's going to be x2 minus x1, and we are going to square that, plus y2 minus y1, and that is a square, and this is all underneath right there. Okay, so we have to find it for all three sides, and once we find it from all three sides, we can decide and classify what this triangle is. So if I'm looking at this right here, this point is 4, 4. And if I'm going from this point right here, this point is 7, 0. So I'm going to plug this in right there. Let's label this. I'll label this as x1, y1, x2, y2. So I put that into my formula right here, and I get d equals x2 is, we have 7 minus 4, and we are squaring this, plus 0 minus 4, and we are squaring that, and this is all underneath a square root. And so this is going to give me 3. 3 squared is 9, plus, and this is going to give me negative 4. Negative 4 squared is 16. When I add these together, that's going to give me the square root of 25. The square root of 25 is 5. So we know, I'll put it off here to the side, we know that BC, that length right there of the triangle, is 5. So all we got to do is find the other two lengths, and then we have, we figure out. Alright, so let's go to AC. AC right here is, we have 0, 1. And again, all I need to do is plug this in. So I'm going to get, I'll label this as my x1, y1. So I plug this in, and we get y2 is, we get 0 minus 1 squared plus 0 minus 1. No, I'm off. This is wrong. Oops, just redo it. I have x2 right here is 7 minus 0 squared plus, and then y2 is 0 minus 1 squared, and this is all square root. So this is going to give me 7 squared, it's going to give me 49, plus this is going to give me negative 1 squared is 1, so this is going to give me the square root of 50. Okay, square root of 50 is not a perfect square root, so we can keep it like that. We could simplify radicals if we wanted to. We haven't talked about that much. You know, you've talked about in algebra before, but I could break this up if I wanted to, and 5 times 10, and this is going to be 5 times 2, and we see that there are 2 5s right there, so we know that AC right here is going to be 5 rad 2. Okay, if you just left it as the square root of 5, square root of 50, that would work too, or we can simplify radicals and put it like that. And then my last step right here is to find, and let's erase this too, this AB length. So we have, let's erase that, AB, so we have A, B right here is 4, 4, and we'll label this as x2, y2. So we have x1 is 4 minus 0, we are squaring that, plus y2 is 4 minus 1, we are squaring that, and this is all underneath the square root. So this is going to be 4 squared is 16, plus 3 squared, which is going to give me 9, so this is still under square root. This is going to give me square root of 25, which is going to give me equals 5. So we know that AB right here equals 5, and we see, hey, these two lengths BC and AB, they are both 5, so we would say those are congruent, and we'd see this right here is an isosceles triangle. So it took us a little work, but we had to know which formula to use, and we plugged in the numbers, and we found out it's that type of triangle. Okay. Alright, so our next problem is this parallelogram? Remember, that means parallelogram. Is it a rhombus? So remember, we just did the booklets that said everything that a rhombus is, and so there's different ways that we can figure this out. If we found out that all the sides were congruent, then we could say it's a rhombus. It could also be a square if that's the case. These angles don't look like they are 90 degrees though, so if we found that, so we could find the distance between all those. But remember, another way that we said that it could be a rhombus is if the perpendiculars, if the diagonals cross, not only bisect each other, but if they create perpendicular angles, right angles right there, then it is a rhombus. That's one of the classifications that does make a rhombus. So how can we figure that out? Well, we talked about before, how do we know if two lines are parallel or are perpendicular? So remember, parallel lines, lines that never cross each other, those have the same slope. But lines that create 90-degree angles, perpendicular angles, they have the opposite reciprocal slope. So that's what we got to do. We got to look, and we have to find the slope. And we can find the slope by doing our formula. We're right up the top here. y2 minus y1 over x2 minus x1. So that's my formula for slope. And we're just going to have all these numbers. We're going to plug it in. So first, if I find out that the opposite reciprocal, then it is perpendicular, which means it is a rhombus. So let's find BD. And I'm going to label it. I like label in front. So I'm going to label this as x1, y1. This is going to be down here. This is going to be right here. Oh, why is it not working? X2, y2. Okay. So we'll say BD right here. Length BD is going to be y2 is 1 minus 4 over x2 is 2 minus 0. So this is going to give me negative 3 over 2. And so that's my slope for BD. So I got to find what AC is now. And again, if it's positive 2 over 3, then it is a rhombus because it would be perpendicular. So I'm going to erase these right here, and I'm going to label these. Again, I like labeling it. This is going to be x1, y1, this is x2, y2. So I have y2, and let's label this is going to be AC right here. AC is going to be 5 minus y2 is 0 over x2 is 4 minus negative 2. This becomes a positive, a double negative. So I'm going to get 5 over 6. So I see that these don't have opposite reciprocal slopes, so I would say it is not a rhombus. And if I had to explain it, I would say that the diagonals do not create perpendicular angles. Remember, this is the symbol for perpendicular, and we'll say angles. They don't create perpendicular angles, they don't make 90-degree angles, so it is not a rhombus. Okay? Alright, on to our next one. Alright, so the last problem that we have right here, and this one you don't need to actually write down. We'll just go through it quickly. We haven't talked about kites in chapter 6, so that's why you don't need to write this one down. We'll talk about it really quick. But again, if you are watching the video, then good for you. Then you don't have to write this one down. It makes it easier because it is a long problem. So it wants to know this kite right here. It wants to know what is the most precise classification of the quadrilateral form by connecting the midpoints of the sides of the kite. So we'll just kind of go through this quickly. If I know all the points on there, we need to find the midpoint. So we have our midpoint formula right here. And all I would do is for each 4 of these sides, I would find the midpoint. So that's what it does. It went right there, found the midpoint, found the midpoint of those lines is 4, 2, found the midpoint of those, which is 4, negative 2, found the midpoint of K and E, which is negative 2, 2, and it plotted all those. So that's a lot of work right there. That's why we're not writing down. We haven't talked about kites either. So now that I have this, I have to figure out, well, what type of quadrilateral is it? Well, it looks like a square, but how do I know it's a square? I know it's a square either that A, it has all right angles. That would be a square, definition of a square. I could see if the diagonals are the same, or if I can see that opposite sides are the same, then that would also make it a parallelogram. So let's see how it goes about doing it. So it says it's finding the distance of each of the lines, so that's 6. This one is 4, BC is 4. Found the distance of CD, which is 6. And the last one, which is 4. So we know that since opposite sides are congruent, then this is a parallelogram. And it says since AB and CD are both horizontal, then and BC and DA are both vertical, so they come together, and that means that they make right angles. Since all 4 are right angles, then this is not only a parallelogram, but this is a rectangle, because opposite sides are congruent and all angles are 90 degrees. So that's how we find that. So lots of work right there, but the biggest thing is just knowing those 3 formulas, and then we'll talk about when to use them, and we should already know how to use them, so we should be pretty good. Alright, thanks for watching.